So what do we want trying to do with all this idea of our stationary points and classifying them? So what we're asked a lot to do is determine the nature of the stationary point of our curves. Now, it's an easy one to start off with because we've got a nice little parabola, and we know if it's a parabola that's concave up, it should be a minimum. So this shouldn't be too hard, but let's prove it using our calculus. So we got the curve there, x squared minus 6x plus 7. We get our first derivative, and we know its stationary points exist when the first derivative is equal to 0. So that's where we get a horizontal tangent. So put the 0 equal to 2x minus 6, and then solving that equation, we get x is equal to 3. So it's not a hard solution there. So when x is equal to 3, we get our y value of minus 2. So it's going to be the point 3 minus 2. And what's our curve going to look like? Well, it's going to be, if we test values before 3, so if I say 2 into the first derivative, that would give us a negative value. At 3, we know it's equal to 0, and after 3, it's positive. So I put say 4 in there. 2 lots of 4 minus 6 gives us a positive value. So our curve comes down, is 0, and then rises, so it must be a minimum turning point. And that's what we're going to be asked to do all the time. So let's have a look at some more problems. X squared plus 4x plus 1. What do we need to do to find the maximum and minimum values here? We get our first derivative. We set our first derivative equal to 0. We get minus 2. And then we get our value of minus 3 when we sub it back into the equation. We test our values. So we know at minus 2 we get a gradient of 0. At minus 3, which is before minus 2, we get a negative gradient, so it's falling. And when it's minus 1, which is after the turning point, we get 2, which is greater than 0. It must be a minimum turning point, because we can see that for minimum turning points, the curve falls, stops, and then rises. And that's what our graph would look like there. This time, minus x squared minus 2x plus 4. Again, get our first derivative, set it equal to 0. We solve and get x is equal to minus 1. We can get our y value by substituting back in the parabola, and then start to test it in this first derivative. So at minus 1 we get 0. At minus 2 we sub it in, we get a positive gradient, so the curve's rising there. And when we put 0 in there, we get a negative gradient, so our curve's falling. So before it's rising, after it's falling, so it gives us a maximum turning point, because the curve rises, is stationary, and then falls. And that's what maximum turning points do. So for this one, it's a little bit harder this time because it's a cubic. So we'll derive. Not too bad though, because we get 3 minus 3x squared is equal to 0. And so I'll solve it, and we're going to get two values for x. X is equal to minus 1, which we start to solve here, and then x is equal to positive 1 from that part, which we'll solve in a moment. So when x is equal to minus 1, we get y is equal to minus 2, and then we can check our gradients there. So we test before minus 1, we get minus 2, and we test after, we get a negative gradient, 0, and then positive. So minus 1 minus 2 must be a minimum. And then after we get x is equal to 1, we said was another value, and we'll get our y value, and then we'll try our values for it before and after positive 1. So if we put a 2 there, because we test 0, and we know we got a positive gradient there. At 1 we get a 0 gradient, and after we tried 2, which we got a negative gradient, so the curve's falling there. So that must be a maximum turning point. So that's what our curve looks like. It's negative gradient, 0, positive gradient, 0, then negative gradient again, which is what our values tell us when we sub them in. So that's what we're looking at when we're trying to determine whether something's a maximum or minimum. A maximum curve rises, then falls, and a minimum curve falls, then rises, and that's what we're looking for with testing our gradients of our stationary points on either side.